In this video, we'll be looking at some more questions on determinants. This is a very interesting question. Of course, it involves some of the results which I haven't discussed with you earlier. I'll be doing them later in detail. Okay, so here they have given delta, which is usual notation for a determinant. Delta is equal to, it says 1a square, a square 1, a square 1a is equal to negative 4. So there is a determinant given to you whose value is negative 4. And the question is to find out the value of this determinant. One approach could be you try and solve this determinant and get the value of a out of it. Then sub in that value of a into this and evaluate this determinant. But it could turn out to be very tedious. So we try something else here. That's why I said it's an interesting question. It's a unique approach in this question. Because the question is set like that, I'm going to call the corresponding matrix as A. I'm saying let A be the matrix. It's the matrix corresponding to this determinant. Let A be is equal to matrix 1A matrix. I made it into matrix. You see the brackets I have changed. It's 1A square, A square 1, A square 1A. And then they said the corresponding determinant is 4. So if this is A, its determinant is negative 4 actually. It says in the question negative 4. So this is given to be negative 4. Determinant A is equal to negative 4, which is being given to us. Now the observation what we are going to make is when you find the corresponding cofactors, these cofactors match with the elements from the second determinant. So I'm going to calculate the cofactor. Now you know how to calculate a determinant. Cofactor is just the signed minor. So you'll put the position sign of the element and not the element, just the position sign into its minor. So I'm going to calculate the cofactors of each of these elements. The first cofactor, that's the cofactor of the element A11, small letter A11 is the first element, right? And the corresponding cofactor is written as capital A11. And what you need to do to get the cofactor of the first row, first column element, that's A11, is put the position sign, you know the position sign is plus, and then delete that row and column it contains. You can see 4 different elements remaining, A square 1, 1A, and that's called its minor. Evaluate its minor. So plus of its minor. What is its minor? A square into A is A cubed minus 1. That's A11. Now A12, that is the minor of, or rather the cofactor of the second element, A12. So I need to first put the position sign which is minus and then it's minor. So I put the position sign minus, delete that row and column. Delete the row and the column it belongs to. You can see 4 different elements, A1, A square A, and you cross multiply. A into A is A square minus A square, which is 0. Now A13, position sign will be plus because it goes like alternate plus minus like that. So it is plus, this is the position sign is plus. Delete the row and the column it contains. You can see 4 different elements. You cross multiply. A into 1 is A minus A raised to 4. A minus A raised to 4. Then I move to the second row where the element is A21. A21. That's the position. A21. So since we ended with plus there, now it has to be minus. Minus because it's alternate plus minus. So for this element, you delete that row and column it belongs to, cross multiply. A into A is A square, minus 1 into A square is A square, which is 0. Next is A22, which will be plus of, this is the element, A22 plus of, delete the second row and second column. You can see the 4 different corner elements, cross multiply. 1 into A is A, minus A square into A square is A raised to 4. and A23 will be now minus of, because this is plus, now it has to be minus. Minus of this, the element, delete the row and the column it contains, cross multiply 1 into, so which 4 elements? 1, a square, 1. Cross multiply 1 into 1 is 1, minus a square into a is a cubed, and I took the minus sign inside, so it became a cubed minus 1. Then I do A31. A31 is for this element. Since we ended with minus there, now this is plus. Plus of, delete the row and the column it belongs to, cross multiply a minus a raised to 4. Next is A32. A32 will be, since it was plus, now it is minus. This is the element, so delete that row, which means the third row, and the second column. You will see 4 different elements. 1 a square, a1. Cross multiply 1 into 1 is 1, and a into a square is a cubed. 1 minus a cubed. You can take the minus sign inside, it will become a cubed minus 1. And then A3 is plus of, because we ended with minus, now it has to be plus. This is the position. So delete that row, which means the third row and the third column. Cross multiply a square minus a square, which is 0. Now this is called the cofactor matrix. If I take the transpose of the cofactor, so these are the cofactors, so the corresponding matrix is called cofactor matrix. And if I take the transpose of the cofactor matrix, it's called the adjoint. So I'm going to find out the adjoint of the matrix A. What I need to do is I should read the first row, but copy as the first column. Read the first row and copy as the first column. So a square minus 1, 0, and a minus a raised to 4. The first row you read and copy as the first column. Now read the second row and copy as the second column. So that is 0, a minus a raised to 4, a cubed minus 1. We copy as the second column. Now I'll read the third row and copy as the third column. So I read the third row, copy as the third column. And that's the time I realize that this is exactly same as what is being given to you in the question. But of course, that is determinant. This is matrix. Adjoint of A is a matrix. But what they want is the corresponding determinant, which means what they want is determinant of adjoint of A. They don't want adjoint of A. Adjoint of A happens to be a matrix, while what they want is the corresponding determinant. So they don't want adjoint of A, they want determinant of adjoint of A, which has a formula, determinant A raised to n minus 1. Of course, I haven't discussed that with you, but that's a formula. Determinant of adjoint of A is determinant A raised to n minus 1. And what is determinant A? Determinant A is minus 4. So it's going to be minus 4 square. I wrote only 4 actually, but minus 4 square or 4 square is going to be the same. How square? Because n minus 1. The order of the matrix is 3. N stands for order of the matrix. It's a 3 by 3 matrix. A was a 3 by 3 matrix. So 3 minus 1 is 2. So minus 4 squared. I wrote only 4 square, but minus 4 square or 4 square is the same. And that gives me 16 as my answer. So this is slightly difficult question. You should watch it one more time, copy the question and do it yourself and learn it. It's from the recent sample paper, so you need to practice it. We look at another question. Without expanding, evaluate, which means at any stage of the question, do not expand. Come up with the answer straight away. That's your answer. You may apply properties, but do not expand. In the question, usually every determinant question at the end, we tend to expand. Like if you remember the questions which we did where we had 1, 1, 1, or rather we make 1, 1, 1, and then we keep 1, 1 there and make the rest into zeros, which you should not do here. Because if you do that, you end up expanding. And they said without expanding. And I can see something. If I look at the first row, the first two elements, they look like a plus b the whole square and a minus b the whole square. The terms are the same. One is a plus b the whole square and the other is a minus b the whole square. And there is an identity on it. See, if you remember all the identities, it strikes you faster. So there is an identity like that, a plus b the whole square minus a minus b the whole square. So I'm going to write that as a note here. a plus b the whole square minus a minus b the whole square. How do I simplify it? A plus b the whole square means a squared plus 2ab plus b squared. Then there is a subtraction sign, so I put the subtraction sign. Then inside a bracket, I expand a minus b the whole square, which is a squared minus 2ab plus b square. Then I start expanding the bracket with the minus sign. Minus a square and plus a square will cancel. Minus b square and plus b square will cancel. Now here this minus into minus is plus 2ab. So 2ab plus 2ab, that's all what is left, which gives me 4ab. So look at this first row, the first two elements there. If I subtract them, basically I'm talking about C1 minus C2. If I do that, how would it look like? A raised to x plus a raised to minus x the whole squared minus a raised to x minus a raised to minus x the whole squared. Doesn't it look like a plus b the whole square minus a minus b the whole square? According to what we proved, it should give me 4ab. So 4 times a into b. And what's my a? My a is a raised to x and my b is a raised to minus x. So 4ab is 4 into a raised to x into a raised to minus x. But a raised to x into a raised to minus x makes it a raised to 0, which is 1. So 4 into 1 is 4. So if I do this term minus this term, since it looks like a plus b the whole square minus a minus b the whole square, I can apply 4ab formula, which gives me just 4. So I want to do the operation C1 changes to C1 minus C2. And if I do that, this term minus this term becomes 4. I already proved, which means it happens in the other two places as well. So all the elements in C1 will now become 4ab, 4ab, 4ab. But that actually works out to 4 into 1, 4 into 1 and 4 into 1. That's 4, 4, 4. I only worked it out for one of them. It works exactly the same way for the other two as well. So C1 changes to C1 minus C2 gives me 4, 4 and 4. Now C2 I will copy the same and C3 I will copy the same. Now you can either take 4 common out of C1 and say C1 and C3 are both same, 1, 1, 1, 1, 1, 1, and so the value is 0. Or you can say C1 and C3 are proportional and so the answer is 0. Either way, I took 4 common out of C1. So I have 1, 1, 1 there. C2 remains the same. C3 is again 1, 1, 1. And if two columns are same, the answer is 0. You should copy down that and then do it yourself. Then only you will learn, not just by watching. Another question. Using properties of determinants, solve. This is a solved question and not a proof question. That's very important when you read the question. You should check if it is a proof question or a solved question. If it is a proof question, I start with the LHS, I apply properties and try to get the RHS. But this is a solved question. So it's an equation. So everywhere I need to keep writing equal to 0. The whole question has to be copied. And the first operation what I am trying to do is I should try and get a common term throughout. And I figured that out quite easily. This is our standard approach. Try adding all the rows together or try adding all the columns together. Here it works both the ways. You can try and add either all the rows together or all the columns together. If I add all the rows together, you can see that 4 plus 4 plus 4, 4 plus 4 plus 4 is 12. Minus x and plus x, one of them will cancel and then there is still a plus x. So I'll get 12 plus x. 4 plus 4 plus 4 is 12. Minus x and plus x will cancel. You still have a plus x. So I have 12 plus x everywhere. Then the other two columns, I'll copy this rows. I will copy the same, which is equal to 0. And then I can see that 12 plus x is a common factor, so it comes out. It's a standard approach now, you see. If 12 plus x common factor comes out, balance will be 1, 1, 1 row wise. First row has 1, 1, 1. Because I took the common factor 12 plus x out, the other two rows, I will copy the same. And since I have 1, 1, 1, I keep the first one there and try to make the rest of them into zeros. Let me copy that one more time and then do it. So I copy this determinant and I'm going to make the other two ones into 0. So let me mark them and try and make them 0. So I want zeros here and 0 here and 0 here. Pretty straightforward operation. If I want 0 here, it's C2 changes to C2 minus C1 and C3 changes to C3 minus C1. So when you do that, C2 changes to C2 minus C1. I have 12 plus x outside. C1 I copy as it is because you are doing column-wise operation. Now from C2 I subtract C1. 1 minus 1 will be 0. When I subtract it here, 4 minus 4 will be 0. Minus x is going to be minus 2x. And 4 plus x minus 4 plus x is 0. Here in C3, 1 minus 1 is 0. 4 minus 4 is 0. X minus x is 0. 4 minus 4 is 0. Minus x is minus 2x. And now I just expand using R1. 12 plus x into 1 into, expand using the first row. 1 into, when you say delete the row and the column it contains, cross multiply. Minus 2x into minus 2x. 4x squared minus 0. The remaining elements are 0, so you don't have to write anything. So I have 12 plus x is 0 or 4x squared is equal to 0. Either the first bracket is 0 or the second bracket is 0. 12 plus x is equal to 0 or 4x squared is equal to 0, which gives me x is equal to minus 12 or x is equal to 0. Go back, copy the question, do it yourself. Next question. Using properties of determinants, show that triangle ABC is isosceles if this given determinant is equal to 0. They give you this value of this determinant as 0. So this is from a past paper and it's also in the NCERT exemplar questions. Okay, so they said prove that triangle ABC is isosceles. So which means we know that capital A, capital B and capital C are the angles of a triangle. You need to prove that it's going to be an isosceles triangle. I need to prove that two of these angles are going to be equal. Okay, so it's not a determinant proof question. It's not that I start from LHS and try to prove that it is going to be equal to 0. It's given to you that this determinant is equal to 0. So I need to copy the entire equation given that this determinant is equal to 0. And I try to do whatever simplification I can on this. One thing is pretty clear here. I have 1, 1, 1 in my first row. So I want to keep the first one there and make the rest into zeros. So I want 0 here and I want 0 here. It's pretty straightforward like the previous question. If I want 0 here, I say C2 changes to C2 minus C1. And if I want 0 here, I say C3 changes to C3 minus C1. I do that subtraction carefully. It's big expression. So when I do that, C1 I will copy as it is. C1 has no change. Change is happening to C2 and C3. So how do I do that? 1 minus 1 is 0. When I do the next element, 1 minus 1 is 0. Cos B minus cos A. So that's all what I have. And when you subtract, always make sure that you subtract similar kind of terms together. So I have a cos square B here minus cos square A. See, cos square B minus cos square A plus I have a cos B here minus cos A. So cos square B minus cos square A plus cos B minus cos A. And when you go to C3 minus C1, 1 minus 1 will be 0. So first element is 0. When I look at my second element, 1 minus 1 is 0. Similar kind of terms you subtract together. Cos C minus cos A. And when you subtract the third element, again similar kind of terms, which means cos square C minus cos square A plus cos C minus cos A. Cos square C minus cos square A plus cos C minus cos A. And don't forget to write it is equal to 0 because it is being given to you in the question. So keep writing equal to 0 everywhere. I'm going to just group a little bit here. Cos square b minus cos square a and cos b minus cos a I group together. Let me copy this step one more time here before I proceed. So I have the determinant coming up, and I was talking about grouping them. See, I made this group. Cos square b minus cos square a and cos b minus cos a is grouped, separate, two groups there. What's the advantage of it? We can see that this cos square b minus cos square a is like a square minus b square. So a plus b into a minus b. So which means I can factorize this as cos b minus cos a into cos b plus cos a. So I have a cos b minus cos a here, and I have a 1 into cos b minus cos a here as well. Look at that. What is this? Cos b minus cos a into cos b plus cos a. This is cos b minus cos a into 1. So don't you get a cos b minus cos a common factor here? What will be balanced? If cos b minus cos a is gone, you will have cos b plus cos a. If cos b minus cos a is gone out of this will be 1. Which means I get a cos b minus cos a common from the second column, entire column. Because this is 0 into cos b minus cos a. This is 1 into cos b minus cos a. This is cos b minus cos a into, balance is cos b plus cos a plus 1. And what happens here? This is 0 into cos c minus cos a. This is 1 into cos c minus cos a. And this is also cos c minus cos a into, balance will be cos c plus cos a. Because if I take c minus a out, c plus a is inside. A plus b is out, a minus b is inside. Like that. So if I have cos square c minus cos square a, it is cos c minus cos a into cos c plus cos a. And this is 1 into cos c minus cos a. And I'm bringing those common factors out. So if I bring that out, I have cos b minus cos a coming out of C2 and cos c minus cos a coming out of C3, and the balance C1 I copy the same because we didn't do anything with C1. From C2, when I take cos b minus cos a, it's 0. This is 1 into cos b minus cos a. If cos b minus cos a is gone out, balance is cos b plus cos a and plus 1 here. So I'll get cos b plus cos a plus 1. And in the next place, cos c minus cos a is taken out, so 0. Cos c minus cos a is taken out, so 1. Cos c minus cos a is taken out, so balance will be cos c plus cos a and plus 1. Cos c plus cos a and plus 1. Of course, this is equal to 0. And in the first row, since you have 1, 0, 0, you will say 1 into its minor, cross multiply. So 1 into its minor. So when you cross multiply, this is cos b minus cos a into cos c minus cos a into 1 into its minor, expand it. So 1 into that whole big term minus this into 1, which is that whole term in brackets, is equal to 0. Now I'll open the bracket and simplify. When I open the bracket, you can see that cos a and minus cos a will cancel. Plus 1 from here and minus 1 from there will cancel. So balance is, you have cos b minus cos a, here you have cos c minus cos a, and there you have cos c minus cos b, that's b actually. Cos c minus cos b is equal to 0. So if the product of 3 terms is 0, that means either the first term is 0, or the second term is 0, or the third term is 0. Which implies either cos b is equal to cos a, or cos a is equal to cos c, or cos c is equal to cos b. Which implies b is equal to a, or a is equal to c, or c is equal to b. So that means in the triangle ABC, either a and b are equal, or a and c are equal, or b and c are equal. So that means for sure at least one pair of angles are equal. Therefore, the triangle has to be isosceles. Look at one more question quickly. Using properties of determinants, prove that this particular determinant is equal to 4abc. It's a pretty simple one. So we copy the LHS because it's a proof question. So I copy this, and as usual we try to get a common term by adding up all the rows together, or adding up all the columns together, or adding 2 rows, 2 columns, whatever. So I'm going to try R1 changes to R1 plus R2 plus R3 to see if there is anything common. So let's try this. To the first row, I add the other 2 rows. I have a B plus C. When I add the other 2 rows, B will become 2B and C will become 2C. So basically this is 2 into B plus C. And here, when I do R1 plus R2 plus R3, I will get A repeated 2 times and C repeated 2 times. And here I will get A repeated 2 times and B repeated 2 times. So which means in the first row, I'll get a 2 common out, and I get only a 2 common out. This is a tip. You should remember this. Whenever you try R1 changes to or C1 changes to, adding all the rows together or adding all the columns together. So like R1 changes to R1 plus R2 plus R3. And if you get only a 2 common out, don't do that. Instead try this. R1 changes to R1 plus R2 minus R3, which simplifies your working. It's not that this one wouldn't work. It would. But this would make it slightly faster. So we want our working to be more efficient. So if R1 plus R2 plus R3 is only giving me a 2 common out, try R1 plus R2 minus R3, which is what I am going to do here. So my R2 will be copied the same, R3 will be copied the same, because they are not under change. Change is happening only to R1. So what's happening? B plus C R1 plus R2. So B plus C plus B, 2B plus C, take away C, 2B. Next, R1 plus R2 will give me 2A plus C and take away C, 2A. R1 plus R2 will give me A plus B and take away A plus B. A plus B, take away A plus B is 0. Then I have a 2 common factor which I will take out of the first row. So it's going to be 2 times BA0, and I copy the other 2 rows the same. Now I see that if I do R2 minus R1, I'll get an extra 0 and the terms will become smaller. So R2 changes to R2 minus R1. So R1 remains the same. Then from R2 I take away R1. B minus B is 0. C plus A minus A is C. And B minus 0 is B. And the third row remains the same. Now again R3. R3 changes to R3 minus R2. Because you get one more 0 and the terms become smaller. This is C minus 0 is C. C minus C is 0. A plus B minus B is A. And since you have 3 zeros, you could just expand it. So just do your normal determinant expansion. So you'll get 2 times B into first element into delete the row and the column it contains, cross multiply AC minus 0 minus A into delete the row and the column it contains, cross multiply 0 into A is 0 minus BC. So when you open, this will be ABC. Here it will be minus into minus is plus ABC. So 2 times ABC plus ABC, which is 2 times 2ABC, which is 4ABC. Again, as I tell you always, you should go back, copy the question and try and do it yourself and repeat it, practice it well.